Okay. 8.3. Scientific notation. Part 1. Okay, so as I mentioned earlier this week, I'm dividing this section, 8.3, into two totally different lessons, okay? Today, I'm going to be introducing just scientific notation, just basic scientific notation, and then we're going to talk about multiplying and dividing with scientific notation. And then y'all are going to do homework. And then the next lesson is going to be dividing with scientific notation. Okay? So, not dividing. Today is going to be that. Adding and subtracting, will be the next lesson. Okay? So, when I say part 1, I'm really referring to the fact that we're doing scientific notation and scientific notation, multiplying and dividing, part 1. Part 2 is adding and subtracting. Okay, let's get started. And bear with me, okay? Pay very close attention. A number is written in scientific notation when it is expressed as a product. What's product again?
Answer to a multiplication problem.
So I'm put a little X there. Whoops. In the form A times 10 to the nth power. I'm going to circle that. That's the form. Where A is greater than or equal to 1, but less than 10. A is the number. A means the number is between. Between 1 and 10. And I'm going to explain this to y'all. This right here, though, this whole part right here, I'm putting stars by because it's very important. So scientific notation. So number is written in scientific notation when it is expressed as a product. It's going to look like this, like a number. A is going to be a number, not necessarily A. It just represents a number times 10 to the nth power, exponent. Where A, this number right here, has to be either greater than or equal to 1 or less than 10. If it is less than 1 or greater than 10, it is not in scientific notation. So this number right here that the back of my pen is pointing to has to be between 1 and 10. So it can be 1, 2, 3, 4, 5, 6, 7, 8, or 9. Cannot be 10. There's going to be decimals, but it still has to be. It could be like 1.345, or it could be 2.067. You're going to be dealing with decimals, but it still has to be between 1 and, let's say, 9. It has to be less than 10, okay? All right? Okay. Let's see this real quick. Okay, here we go. For example, let's say the number is 29,500. And we need to put it into scientific notation. Remember, the number has to be between 1 and 10. This is not between 1 and 10, right? Okay, this is how we do it. Now watch. I'm going to put an imaginary decimal here because we got to get it between 1 and 10. I'm going to move the decimal 1, 2, 3, 4 places left. So now I have 2.95 times 10 to the, how many places did I move that decimal?
4.
To the 4th power. There's that number in scientific notation.
So that's what we're doing today.
Oh, you wish that's all we were doing today. What?
How do you know how many places to move it?
Because right here, 2.95 is between 1 and 10. So you have to move it to where it's going to be between 1 and 10.
So it won't always be 4. It could be more.
That's right. It could be more, it could be less. Basically, for it to be in correct scientific notation, you're going to have a number, point, something else. Or you'll just have a 2 there or something like that. But you will always have just a number, decimal, and then everything else. Because really, that number right there has to be between 1 and 10. So you will always move it to where, either left or right, to where you only have one number there, between 1 and 10. We're going to do lots of examples. Notice also, take note, that this, the 4 places here, is where we put the is what the exponent is. However many places is the exponent. Also take note, it's positive. You'll need to remember that later. Because yes, we will be dealing with negative exponents in scientific notation. Okay. Let's do some more. Everyone have it down? All right, star. When putting a number into scientific notation, I'm abbreviating it. When putting a number into scientific notation, if you move decimal left, the exponent is positive. So if you're putting a number into scientific notation, if you move the decimal left, the exponent is positive. if you move the decimal right, the exponent is negative. So what we just did up here, we took a basic number and we put it into scientific notation. We moved the decimal place to the left to get it between 1 and 10. Therefore, the exponent is positive. But if we were to move it right, and I'm going to give you an example, then the exponent would be negative. Now, you can memorize that, or you can learn Mrs. Rogers' way. Now, Mrs. Rogers' way may not make sense to other teachers and people. It works all the time unless you have some weird number. But I've had students that will ace their tests and quizzes based on Mrs. Rogers' way. I've had students that ace based on this. Normally, whole number has positive exponent. So normally, whole number has positive exponent. Big, ugly, it's just like intruder alert. It's capitalized because I've invented it. It's a formal name. Big, ugly decimal. We're going to call it big, ugly. Big, ugly decimal number has negative exponent. So whole number, positive exponent. That's when you're putting it into scientific notation. Big, ugly decimal has a negative exponent. And I'm going to give you an example of big, ugly. So when putting a number into, that's the key word, into scientific notation, if you start off, now listen to what I'm saying, if you start off with a whole number, isn't this a whole number? This started off as a whole number, right, Cecilia? Then the exponent is going to be positive. If you start off with big, ugly, it's going to be negative. Here's an example of big, ugly. And I'm serious. This is what you'll be seeing. 0 1, 2, 3, 4, 5, 6, 7 zeros, 4, 3. That is big, ugly.
Whenever you're saying 1, 2, 3, 4, 5, 6, 7, I literally wrote 1,
Yeah,
2, 3,
same.
4,
Oh,
5,
sorry.
6, 7.
Sorry, write this. This is an example of big, ugly decimal. So let's say they give you this and say put that into scientific notation. Now remember, there's 7 zeros in between. There's 7 zeros in between. No, right here. 1, 2, 3, 4, 5, 6, 7. So remember, to put it into scientific notation, the number itself has to be between what? Is this between 1 and 10? No, to get it to be between 1 and 10, remember I said always have like a number and then the decimal. We're going to need to put it right here. So I'm going to move it right 1, 2, 3, 4, 5, 6, 7, 8. Right there. So 8 places right. And therefore, we get 4.3 now. Isn't that between 1 and 10? You see that, Cecilia? So 4 is between 1 and 10, yes? So we have one number point and then the rest. It's big ugly. We moved it 8 places, so it's times 10 to the negative 8. And there's my answer.
Why is it called scientific notation?
I don't know. I'm sure your book explains it. That number is between 1 and 10. And unlike the last couple of days where I'm like, nope, you can't have negative. You got to put that under 1 so that it becomes positive. In scientific notation, it is okay.
Yes.
Oh, just wait though. Yes, sir.
I like
Do we always, or are we always gonna have the 10? Like,
It's always going to be 10.
okay.
Any questions? That is big ugly.
Mr. Upton.
I'm serious. You're going to hear, just like intruder alert, I'm going to say, oh, look, that's big ugly. Okay? This is normal. That's whole number. That's normal. That is big ugly. Makes sense. That's big and ugly, right? Okay. Any questions? No questions. All right, let's do another. This time, we're going to have it already in scientific notation. And we want to see what the regular number is. So write that down, and then I need y'all to look up here. All right. Guys, that exponent, positive or negative? That's positive, right? So then is your answer going to be a normal whole number, or is it going to be big ugly? That's right. If it's positive, then your answer is going to be normal whole number. That's your little clue. So if they give you scientific notation and they want you to, tell us what the number is, then if this is positive, then your answer should be a normal whole number normally. But if it's a normal whole number, we're going to have to move this decimal either to the left or right. If I move it to the left, it becomes a big ugly decimal, right? But since this is positive, I'm going to rewrite this here. We're going to move our decimal 5 places to the right. 1, 2, 3, 4, 5. And fill in with zeros. Make sure your notes are nice and neat so you can refer back to them. So therefore, my answer is 2, 1, 0, 0, 0, 0. There we go. Positive exponent means normal whole number. Not big ugly. I'm going to do another example, and then you see the difference between the two, and you can ask questions. Let's say I have 6.8 times 10 to the negative 6 power. So it's already in scientific notation. Notice each time this number is between 1 and 10. 1 and 10. Okay, so now I have a negative exponent. So then my answer is going to need to be big ugly. So this time, to make it big ugly, I'm going to move this decimal to the left 6 places because that exponent is negative 6. So 1, 2, 3, 4, 5, 6. And I'm going to put my decimal right there. And I have filling in with zeros. So my answer is 0.0000068. There's 5 zeros here, and I have 1, 2, 3, 4, 5 zeros there. And yes, I will count your zeros. Do you see that this is big ugly? Negative exponent in the scientific notation, the regular number is going to be a big ugly. Now, look at the two together. See if you can see the difference. And if you have questions.
You should trademark Big Ugly.
Along with intruder alert.
Yeah.
Any questions? Y'all have this down? Okay, so both of these are correctly written in scientific notation. But if they ask you to put it in regular number, if this is positive, you move the decimal right. If it's negative, you move it. Oops, I didn't even write that. 6 places left. So if it's negative, you have to move it 6 places to the left. If it's positive, you move it to the right. And again, if you can't remember those rules, just remember the end product. If it's positive, it better be a normal whole number. If it's negative, it better be big ugly.
So whenever we go to the left once, that counts as a place. It's not just 6 zeros.
That's right. Any questions? Okay, so Sue, you can't see, and it's hindering. You need to move up, okay? Okay, moving along. Now we're going to talk about multiplication and division. So you've learned about scientific notation, how to put it into scientific notation, how to take it out. Now you're going to be multiplying and dividing in scientific notation. So multiplication and division with scientific notation. This stuff isn't bad, believe it or not.
Is that correct?
It's a little worse. All right, y'all ready? Here we go. 7.5 times 10 to the negative 5 power times, because we're multiplying, 2 times 10 to the third power exponent. Write that down. What you're going to do is you're going to group. Okay, so 7.5 times 10 to the negative 5 exponent power times 2 times 10 to the third power. Now, you're going to group. Watch what I do. (7.5) times 2, and then we're going to do 10 to the negative 5 power times 10 to the third power. Watch this. 7.5 times 2, because remember we're multiplying, times 10 to the negative 5 power times 10 to the third power. So 7.5 times 2, see, I've got those grouped. So I've just taken the two regular numbers, put them into a group. Again, we're multiplying, so then I'm taking the 10 to the negative 5 exponent times 10 to the 3 exponent. .5 times 2 is 15. 7.5 times 2 is 15. Times, now remember, if the bases are the same and we're multiplying, what do we do to the exponents?
Add.
So that would be 10 negative 5 plus 3, which gives you what?
No, -2.
So it would be times 10 to the power of negative 2.
This is null with that.
So 7.5 times 2 equals 15. And then 10 to the 5th power times 10 to the 3rd power, bases are the same, so we add the exponents. That gives us 10 to the negative 2 power. Now, question. Is this number between 1 and 10?
No.
No. Number not between 1 and 10. So we have to fix that. We have to fix it. So just like we did right here, by moving the decimal to the proper place, we're going to have to do that here. So I'm moving the decimal, starting here, imaginary decimal, and if I move it just one place, then I get 1.5. Is that between 1 and 10?
Yes.
Yes, it is. But right here, it was a whole number, correct? So I moved it one place. So how many places? 1. So then I'm going to add plus 1. Because if I move it one place, and it's a whole number, so we're adding 1, because it's not big ugly, then I get 1.5 times 10 to the negative 1 exponent. So, it's a whole number, it's not big ugly. So we're going to have a positive exponent, right? So we moved it over to make it between 1 and 10. And since we moved it one place, and it was a whole number, we're going to add a positive to the exponent. -2 and +1 is -1. That's the answer. Questions? Yes.
So over here, the one that's not your method, it says if you move it to the left, then the exponent's going to be positive. And isn't that what
We moved it to the left. The exponent is positive.
Oh, just the one that you're adding.
That's right. Okay, so Michaela had a good question. She said, it says in the notes that if we're putting it into scientific notation, if we move the decimal left, then it's a positive exponent. And she's correct. They're not saying the answer, they're saying that's +1, +1. So we add that to the exponent, and then we get that. Good question. Yes, Aiden? You're going to miss all this. Okay. Any other questions? All right, let's move on. Example. What if I have 1.2 times 10 to the negative 4 squared? Now, based on the exponents and the rules with them, you can do this in one of two ways. You can either rewrite this as 1.2 times 10 to the negative 4 times 1.2 times 10 to the negative 4, or you can apply it based on the rules to everything in there. So then you have 1.2 squared times, what's 2 times negative 4? Anyone? 10 to the negative 8. Good job. See, that's not bad now. Now, we have to finish this. 1.2 times 1.2. Raise your hand if you know what that is. Taylor? What? What?
1.44.
1.44.
How's that?
So, our answer is 1.44 times 10 to the negative 8. Question. Is this number, Cecilia, between 1 and 10? She's correct. 1, and whatever the decimal is between 1 and 10. So, you're done. There's your answer. Not too bad, right?
I think I like this better than the other stuff.
Oh, just wait. Any questions about multiplying? Okay, so remember, if you're multiplying, you just group the numbers together, times, and then the tens and their exponents together. The bases are the same, so you're going to add the exponents, multiply these, then make sure it is in scientific notation between 1 and 10 and move the decimal. If we had to move it this way, we would be doing -1 or -2 and combining it. In this case, it's just you square everything inside the parentheses, finish this out, and then there you go. Make sure this is in scientific notation. You're good to go. Any questions? All right, let's talk about division. 2.4 times 10 to the 7th power divided by 6 times 10 to the 2nd power. Okay, what I want y'all to do is rewrite this by stacking them, kind of like what you've been doing with exponents. You're going to write 2.4 times 10 to the 7th power, because it's being divided by this, over 6 times 10 to the 2nd power. So, 2.4 divided by 6. I'm going to save you, Gabby. That's right. 0.4. Good job. 2.4 divided by 6 is 0.4. Now, raise your hand if you remember the rules. If the bases are the same and we're dividing, what do we do to the exponents with?
You subtract.
That's right. So it's 7 minus 2, which gives me 0.4 times 10 to the 5th power. Are we done? Some people are saying no. Michael, why am I not done?
Because 0.4 is less than 1.
That's right. Number is not between 1 and 10. So, we have to move the decimal. Keep in mind, this does not look like this with all the zeros, but is this a whole number?
No.
So it is still considered big ugly. So what do I need to do, Michaela, to put this into scientific notation, correct scientific notation? Move the decimal where?
You're going to move the decimal to the right once.
That's right. We're going to move it to the right one place. So therefore, I have 4 times 10. Now, if it's a big ugly, am I going to have do I add or subtract an exponent? Gabby? That's right. So I have 5 minus 1. I moved it one place to the right, so it's going to be negative move, minus 1. Big ugly, negative move. So then 5 minus 1 is, so 4 times 10 to the power of 4. And then we're done. Any questions? Yes, Taylor.
Are we gonna be doing any problems where the base number is negative?
No.
Okay.
No.
Great. It's good.
Would that work opposite of what we're doing now?
I don't think it would really affect it much.
Okay.
All right, so what I want you to do is open your books to page 341 for examples. All right. It says express each number in scientific notation. So they give you this number and they want you to put it into scientific notation. Okay, this is clearly not between 1 and 10. Cecilia, tell me what to do.
3 here.
Wait, what? I didn't hear you.
You put a decimal between 3 and 9.
Okay, so we're going to move the imaginary decimal. And she's correct. We're going to put it between 3 and 9 to make it between 1 and 10. How many times did we move it?
8 times
Okay, and is that a positive 8 or a negative 8?
positive.
That's right. And there's your answer.
Or am I just weird?
You're just weird. Keep in mind, this started off as a whole number. So, plus 8. Good job. Any questions?
So? Oh, so.
Plus 8.
I was like, is that 50?
All right, number 3. 0.12345 2. Already, what do we call this? Big ugly. Big ugly.
Just like a Jeep truck.
What?
Truck. The Jeep, you don't like Jeep trucks.
No, they're not ugly.
Jeep trucks.
Okay, it's big ugly. And this is clearly not between 1 and 10. That's so random, Taylor. This is not between 1 and 10. If it's big ugly, that's going to do something to our exponents. So, let's see. Michaela, where do I need to put the decimal?
You're gonna put it between the 5 and the 2.
That's right. Now, if it's big ugly, what does my exponent look like? Negative what? Mm-hmm. There's your answer.
I'm glad we don't have to put it over 1 at all.
No. Any questions? Moved it 5 times. It's big ugly, so it's negative 5. All right, number 5. 13.6 times 10 to the 7th power. We need that. Some of my students will say, well, wait, this is already into scientific notation. Is it really wit? No. So what do I need to do to put it into scientific notation? Because this number is clearly not between 1 and 10.
You're gonna move it left 1 place.
I'm going to move it left 1 place. Now, this is pretty much like a whole number, correct? We started off, even though there's a decimal here, is it a big ugly?
No.
It's not even like this, right? It has a decimal in there, but it's not big ugly because 13 is a whole number. So we moved it 1 place, so my answer is what?
1.36 times 10 to the 8th power.
That's right, because it had 7. We moved it 1 place. This is not big ugly. We moved it left 1 place, so we're adding 1 to that. So then my answer is 1.36 times 10 to the 8th power. That is not big ugly. So we are adding 1. Any questions? None? So you got it? All right. 11. It says express each number in standard notation. That means give me the actual number. It's in scientific notation. Yes? This is between 1 and 10. That's, scientific notation. Now, notice negative exponent. So the answer should be what?
Big ugly.
Big ugly. Move dot left. So the answer should be big ugly. Now I'm going to write the answer there in a minute. So I'm going to go ahead and rewrite the 1.53. If the exponent is negative, And we have to get, so you got to know if the exponent is negative in the scientific notation, then the regular answer has to be big ugly. If I were to move this 4 places to the right, I would be making it into a nice big whole number, right? Correct? So if I'm expecting big ugly, I got to move it left. 1, 2, 3, and it says 4 places, so 4 places left. Fill in the zeros. So it's 0.00153. Again, if the exponent is a negative in the scientific notation, then the standard, the regular number, needs to be a big ugly. So you need to move it to the left. Again, if you're like, man, I don't remember if I go left or right, then watch if I do this. If I were to have 1.53 and move it 4 places to the right, 1, 2, 3, 4, then I would have this number. Is that a big ugly? That's big ugly? That's a whole number. So that's wrong because it has a negative exponent. Any questions? Now I'm going to write 4 places left. Any questions? All right, 13. 2 times 10 to the 2nd power times 3 times 10 to the 5th power. What, you have a question?
Can I do it?
Yeah, sure. So what do I do?
Combine the 2 and the 3, and then the 10 squared, and then the 10 5.
That's right. We're going to group 2 times 3. So I'm going to group my regular numbers times, because we're multiplying, and then 10 squared times 10 to the 5th power. So what 2 times 3 is?
6.
Times 10. Now, if my bases are the same and we're multiplying, what do I do to the exponents?
You add the exponents.
So that's 2 plus 5, which gives you what?
7.
Is this number between 1 and 10?
Yes,
So we're done. Any questions? None? So you got this? Okay. Let's look at 17. It's 4 times 10 to the 11th power divided by 8 times 10 to the 4th power. So division, remember what I said, rewrite these by stacking them. Can I do 4 divided by 8? Or can I just put these in lowest terms? Aiden, what would 4 over 8 be? 1/2. Times 10. Now we're dividing. The bases are the same. So what do I do to the exponents? Anyone? Subtract. So I have 11 minus 4. So I have 1/2 times 10 to the 7th power. Now, in scientific notations, do we have fractions? So how would I write that in a decimal? 0.5 times 10 to the 7th power. Oh no, Aiden. Is this in correct scientific notation? So I need to move it, right? Move the decimal. Is this a regular whole number or is that a big ugly? 0.5?
Oh, sorry. Big ugly.
It's a big ugly. Big ugly. It's a total decimal. So, which direction do I move the decimal?
Right.
How many places? So then I have 5 times 10. Now, if it's big ugly, do I add 1 here or subtract 1 here? That's right. I'm going to subtract 1 here because it's big ugly. Moved to the right, so then it's minus 1. So then it's 6. All right, big ugly. Any questions? All right, I'm moving. Your quiz is going to be Monday.
Thank you.
Your quiz is Monday. We are out of time. So tomorrow I'll have your assignment, and in class you will work on this. If you on Google Classroom, I did assign some iExcels. Make sure you work on those every chance you get. That's whenever the deadline. Tuesday then. Whatever that I put on your Google Classroom. iExcel due Tuesday. Thank you for telling me. I couldn't remember.
The 2 that you signed yesterday, they were just for to give us time to do it, right? Or are they actually?
These were the ones that I signed, wasn't it?
Were they
But on the board, you told us to do 2 specifically.
That's what I
On the board?
Yes, ma'am.